Do you guys feel that our surroundings getting warmer nowadays? And do you guys ever think about any technology that might keep our environment from getting warmer and warmer? If you guys don't, here my group and I will explain to you about an interesting technology that can help to cool down our environment. Assalamualaikum warahmatullahi wabarakatuh and a very good day. Today our group will present about an interesting topic about green technology, which is cool pavement. Before we proceed to the next part of our presentation, let me introduce myself and my other group members first. I am Asyraaf Hafiz with match number 207592. Next we have Nurul Arifah Kamal with match number 208047. We also have Nurul Athirah Yusni with match number 207701. Then we have Shamila Kamal Arifin with match number 207777. And lastly, our group have Ayuni Umairah Kamaruddin with match number 208202. Pavement represents the largest percentage of a community's land cover. As we all know, pavements are the critical elements for the transportation in many aspects, especially in urban areas. People will use it for walking, riding in passenger vehicles, carrying goods in commercial vehicles, providing mobile services, and also as a parking area. By altering the common pavement that we currently use, it can help in addressing the problem of urban heat islands. What is urban heat islands? Actually, urban heat island can occur when a city experiences much warmer temperatures than nearby rural areas due to the massive development that happen in certain countries to accommodate growing populations, such as concrete buildings and asphalt roads. These surfaces then will absorb the sun's heat and causing overall ambient temperatures to rise than usual. Cool pavements can be achieved with existing paving technologies and do not require any new materials. Briefly, we just need to focus on how to make the pavements tend to store less heat and lower the surface temperatures compared with conventional products based on the choice of materials and engineering design, which will be explained more detail by my other group members. So without further ado, I will pass the presentation to Arifah to explain more about our topic, cool pavement.
Thank you, Asyraaf. Now, I'll proceed today's presentation with the modifications of pavement materials to keep them cool. Firstly is by reducing the pavement thermal conductivity. As we know, thermal conductivity can be defined as the ability of the materials to conduct or transmit heat, and it determines how fast and easily the heat could be conducted from high temperature region to a lower temperature region. Thus, by reducing the thermal conductivity, the pavement may heat up at the surface, but it will not transfer the heat throughout the other pavement layers as quickly as those with high conductivity. Next, the second modification that could be done is by increasing the pavement heat capacity. Heat capacity is the amount of heat required to raise the temperature of one unit weight of substance by 1 degree Celsius without the change of phase. Thus, it determines how much energy will be absorbed and stored in the pavement at certain temperature. So, increasing the specific heat capacity could increase the effective heat capacity of the whole pavements and help to reduce the daytime high temperature. The third point is to increase the pavement surface convection. So, the rate of convection actually depends on several factors such as temperature and the velocity of the air, the pavement roughness, and also the total surface area that is exposed to the air. Thus, what I can say is that the pavement with rougher surface will increase their effective surface area and creates air circulation over the pavement. Furthermore, the pavement materials can be kept cool by increasing its surface reflectance. Surface reflectance is also known as albedo, which refers to the percentage of solar energy reflected by a surface. This means that by having high albedo, the subsurface temperature of the pavement can be reduced, since less heat is available at the surface to be transferred into the pavement layers below the surface. And the last point I would like to touch is by increasing its thermal emissivity. A material's thermal emissivity determines how much heat it will radiate per unit area at a certain temperature. It is actually almost the same with the albedo that I've mentioned just now, but while albedo have a large impact on maximum surface temperature, the emissivity is affecting the minimum temperature. And similar to albedo, if the increased radiation from pavements directly goes back into the space far away, it might help to reduce heat island. And I think that is all from me. I will pass today's presentation to Shamila.
Thank you, Arifah. Okay, now I will continue the presentation with the types of cool pavement. Actually, there are so many types of cool pavement, but today I'll just share with you 3 examples of cool pavement. So the first one is permeable type. The permeable pavements have a rough surface and more void contents, which can increase their effective surface area exposed to air and create air turbulence over the pavement. This will increase the convection between pavement and air, thus help to reduce the pavement temperature. Besides, it's designed to allow water to drain through the surface into the sublayers, which can prevent dryness. This permeable pavement includes the non-vegetated and vegetated permeable pavements. On this slide, you can see the examples of the vegetated permeable pavement. Next is conventional concrete type. Conventional pavement is occasionally called rigid pavement, as it is made by mixing Portland cement, water and aggregate. The conventional concrete pavement generally has a higher reflectance. It can be modified to increase the reflectance by using white cement or cement blended with light color slag. Lastly, the roller compacted concrete type. This pavement type is specially mixed and placed form of concrete, which contains essentially the same ingredients as conventional concrete, but in different proportions. It is commonly used for heavy hauling works since it is more durable and high resistance to abrasion. So there is no concern about the high temperature effect due to hot weather or from the vehicles. That's all from me. I will hand it over to the next presenter, Athirah. Thank you.
Thank you, Ain. Now, I will proceed with the benefits of cool pavement. Installing cool pavement can be part of an overall strategy to reduce air temperatures, which can result in a wide range of benefits. So, the first benefit is that cool pavement can slow climate changes. Researchers predicted that pavement reflectors throughout a city will increase from 10% to 35%. The air temperature could be potentially reduced by 0.6 degrees Celsius. This will result in a significant benefits in terms of lower energy use. So, here I attached the example that shows the temperature reduction between dark asphalt area and cool pavement area. The temperature of the dark asphalt area that usually covers the road was measured more than 65 degrees Celsius, while the temperature for the cool pavement area measured was almost 58 degrees Celsius at the midday when the outside temperature was 40 degrees Celsius. Hence, we can conclude here that temperature of dark asphalt area is higher compared to the cool pavement area. Secondly, cool pavement can create improvement in water quality. It can address water quality problems by reducing percentage of land coverage by impervious surfaces. When combined with water treatment wetlands, these pavements help to act as filters. Therefore, it can finally improve the water quality and provide greater groundwater protection. Thirdly, cool pavement may help in a nighttime illumination. European road designers often take pavement color into account when planning lighting. This is because more reflective pavement can enhance visibility at night. This can potentially reduce lighting requirements and save both money and energy. Last but not least, the benefits of cold pavement is that it can enhance driving safety. Better water drainage can enhance safety by reducing water spray from moving vehicles. This may increase traction and may improve visibility by draining water that can increase glare. That's all from me. I will pass to Ayuni to explain the challenges of cold pavement. Thank you.
Wow! Thank you, Athirah, for a great information. Next, I will bring you to the next segment of this presentation, which is the challenges of cool pavement. All technologies in this world for sure have pros and cons. Despite the pros of global cooling and increased human comfort, this innovative technology also does have some apparent cons. Do you want to know what is it? So, let's move to the next slide. The first one is brightness. But what does it mean by brightness? For your information, there are two types of materials that being used in order to create cool pavement, which are cement and asphalt. However, comparing these two materials, cement have more disadvantages than asphalt. So, the points that you see in this slide are mainly focused on the consequences of using cement as cool pavement. Usually, cement comes in a lighter color, like white. So, the lighter color will give the higher albedo, or in other words, is a higher solar reflectance. This will give discomfort and glare to the human. Furthermore, the process of making cement also required more energy and carbon intensive than the production of making asphalt. The next one is energy. New research from the Departments of Energy Lawrence Berkeley National Laboratory, they state that energy output for making cool pavements is greater than the energy savings that this technology yields. As one of the lead researchers said that maintaining a reflective coating would require over 6 times as much energy as a slurry seal, which means that the slurry seal is only rock and asphalt, which requires little energy to produce, while the reflective coating contains energy-intensive polymer. And last but not least is cost. Comparing the cost of cool pavements with those of conventional materials is difficult. The cost of any pavement application varies in many things, such as material chosen, local availability of materials, underlying soils, expected traffic, and more. Communities that want to use cool pavement as part of a heat island mitigation program may find it is hard to estimate the net cost or benefit based on the temperature reduction alone. So, as all of the important things that have been presented, I will pass the floor to Muhammad Asyraaf to conclude our presentation for today.
Now, we have reached the end of our presentation. To conclude our topic on cool pavements, additional research should be developed to widen the knowledge and experience about this new invention. We should dig more information on how this technology behaves, what designs are feasible, where and how they can best be applied, and what are their benefits to us, based on the points that my group members present just now. There are few departments that could play an important role to make this technology more realistic. Firstly, technical research. They should refine more promising materials and designs to construct an approach on how to reduce the capability of heat island. After that, economic researchers should refine the information on initial cost of techniques and life cycle performance of this pavement. Organizational researchers should also focus to increase the awareness and promote the use of cool pavements in public and private sector agencies. Last but not least, institutional research. They could focus on ways to communicate about the success stories of this technology to gain more trust from authorities to apply more cool pavements around the world. With all of these efforts, it can definitely be used to help lower the temperature of our Earth from giving disasters to us back as human beings eventually. Well, that's all from us. Thank you for your attention.